Without physics research, there is nothing.
Everything that we see that are being developed, it starts from basic scientific principles.
In making decisions for the well-being of people, a government or a company or a family need to know something about those decisions. They need to know what they're talking about, need to have an understanding of the consequences of their decisions. And very often that comes from scientific research.
In a world filled with questions, scientific research continues to provide many of the answers. The role that science must play in creating the knowledge needed for realizing the world's vision for sustainability is a crucial one. And with 2022 as the International Year of Basic Sciences for Sustainable Development, the link between applications of basic sciences and Agenda 2030 for Sustainable Development cannot be overemphasized. The 17 goals that form part of Agenda 2030 are to ensure the balanced, sustainable, and inclusive development of the planet, all of which are influenced by science and technology. Some of the goals that form part of this agenda include affordable and clean energy, climate action, and clean water and sanitation.
SDG.
Ooh, SDG, I've got no clue about that one. SDG.
I know it's about developmental goals, but the S is what I'm trying to remember stands for what.
Oh, I thought I know. Unfortunately, it just came out of my mind.
Social something about grant.
SDG stands for Sustainable Development Goals.
So damn great.
SDG stands for Sustainable Development Goals.
The few development goals that I know about is the eradication of poverty.
Conservation, nature conservation.
I know one about the healthy objectives.
It is equal education for everybody in society.
Environmental.
And the development of sustainable water sources. I know water is a very key part of living on Earth.
The role of basic science is essential in ensuring sustainable development for humans. Think about one of the essential ingredients to have sustainable development in energy or innovation, technology. All these are based on knowledge. And basic science is a unique way to understand how these energy and technology are based on.
The Itamba Laboratory for Accelerator-Based Sciences brings together scientists working across a wide range of research areas, providing opportunities for modern, groundbreaking research. Itamba Labs is Africa's leading research facility for accelerator-based science.
The role of Itamba Lab in scientific research is very diverse. All of them, though, are based on the fact that we use accelerator, particle accelerator. Accelerator is a machine that allows us to take one element, let's take hydrogen, and from this hydrogen bottle, you extract particle per particle these atoms called hydrogen and accelerate them to a speed that allows to actually see very tiny object on any matter. And my eye cannot see it, but we have detectors with the accelerator that are sensitive to this high energy particle and sees inside you. There is another application or science based on uses of accelerator, which is that we don't use the accelerator at Itamba Lab to map or scan the interior of object, but we just modify object. So we start with something that is stable element, and we create a radioactive element. And these radioactive elements, we call them radioisotope. So we produce these elements that decay and die very quickly, and we use them as a radiopharmaceutical. Sometimes you need to go and have a scanning of what we call PET scanning or SPECT scanning, which is the possibility to diagnose cancer. In order to see whether we have a tumor, we go through this type of scanning, and the scanning is possible only with this radioisotope. Not only that, this radioisotope now, Itamba Lab is working with other facilities in the world to produce those who will kill the cancer. So what we call therapy with radioisotope. So diagnostic and therapy.
So I am an experimental particle physicist. I work in the ALICE experiment, LSC, at CERN. What we do actually is we want to study the universe, like how the universe is created. Basically, it is a fundamental research. It is not application research, but it indirectly affects the people's life. Like it will give you the new technology innovation. The best example is the www, the World Wide Web. So it was created in the CERN. And also the technology you are using in the mobile phone also, it is same came from the CERN. So it will indirectly affect all of your life. The impact I want to make in my research, I want to teach the children the physics and how it is interesting to know about the worlds and basically the particle physics, how it is interesting. If I motivate only one person also to do and come the same research as me, so it will be a great impact.
Material science is all around you. Your clothes, your shoes, your glasses, the car that you traveled this morning, the tires of that car, the tar road, everything, the robots, everything is about material science. If you zoom into any material, it consists of a lot of small particles. Most of the time we are working on nanoparticles. In our case, we are looking at everything that's glowing. So if you shine some electrons on it, X-rays on it, ions on it, you're getting some beautiful light coming out of that. You've seen it this morning when you're driving your car, on your dashboard. All that light that's shining there is light-emitting diodes. And what we are doing is we are trying to improve the efficiency of that material that you're using in that light-emitting diodes. And then we're also looking at some materials that we add on top of solar cells. So we're going to improve the efficiency of solar cells by using our particles that's glowing. We're going to help people in rural areas. They can have some soft luminescence at night of long afterglow phosphors. And then we're even going to put some phosphors in windows. And then we're going to absorb the light, the UV light and infrared light, the stuff that you don't see, and then we convert it to electricity.
Coinciding with the International Year of Basic Sciences for Sustainable Development, 2022 also marks the 100th year of the International Union of Pure and Applied Physics, an organization with a mission to assist in the worldwide development of physics. As we celebrate their centenary, let's look back at some recent notable physics discoveries. Research and innovation are all necessary parts of the journey to creating the future we want to see. The Council for Scientific and Industrial Research, or the CSIR, is a world-class African research and development organization, the biggest of its kind in Africa.
The Center for High Performance Computing, it's a national facility. We realized that when you use a single computer, you don't get far enough to be able to make meaningful discoveries. So for you to be able to study complicated systems, for an example, if we need to know how cold is it going to be tomorrow, we cannot do that only with a single computer. So we have what we call high performance computing, which means that you bring together many computers linked together and you let them do a specific task. So that is what is high performance computing. And its key role is to make sure that South Africa can be competitive. In material science, which is mainly from my background, we have got a number of things like from mineral processing. We have got research that is going into pharmaceuticals, where we're discovering new medical products. Bioinformatics, for an example, that is more looking at the genomic sequencing, so for genetic research. We also have got research that takes place in climate change, which is the key thing that South Africa is participating in. Big astronomy projects, you might have heard about the Square Kilometre Array. That is a big project that is happening in the world and is hosted by South Africa. So these are all driven by the Center for High Performance Computing.
My area of research is in material science, but material science is very broad. So it goes down to gas sensing. So I can say gas sensing is my area of research. I do my research at CSIR and here at FETS. So when I'm synthesizing my materials, I'm here at FETS. And when I'm doing gas sensing part of the research, I go to CSIR. And sometimes when I see I need to explain more, I come back here at FETS and then characterize again. When there is a gas leak, we know we have sensors. You can see, you can smell, you can at least feel on your skin like something is wrong. But these ones, they get fatigued and you won't be able to tell sometimes. So gas sensor technology, we have these electronic noises that won't get tired of telling us that there's something wrong in this room. We all want a clean environment, right? And these gas sensors, they will help you to detect what's in the atmosphere and will let you know when there's something wrong. So in my area now, I'm working with metal oxides, and I'm targeting carbon monoxide. So knowing that there is carbon monoxide, people must leave the building or the environment immediately. I think it's a lot, and that's contributing to the society to make sure that in terms of health, they are not having these toxic gases in the environment.
Understanding our environment sometimes requires us to look up. Space science is a field that is critical for the understanding of our planet, and yet this is an area of research often misunderstood by the community at large. What relevance do space-related activities have in our world?
The importance of space science research is to understand the physics that governs the different and complex processes that occur in the geospace environment. To give you an example, the navigation that we use on our phones and our cars as well as airplanes is obtained from information that we receive from satellites known as the navigation satellites, such as the Global Positioning System, or GPS for short. My area of research is the study of the ionosphere, which is the ionized part of our atmosphere. I use physics to try and understand the processes that causes dynamical changes on the ionosphere, which then affects a radio signal as they propagate through it. This is important, for example, for satellite communication, because if you have disturbances in the ionosphere that impedes this communication, then we have a problem. So we need to find mitigation actions in order to counter these disturbances.
So without space science, we wouldn't have solar energy or solar power in our homes. For example, the solar panels were originally designed to harness energy from the sun and power satellites in space. This technology has now incorporated in our home as an alternative way of providing energy or power, such as heating up geysers using solar energy.
So SANS's mission and goal is sort of multifolded. One is to support nascent South African industry. One way we do that, for example, is the Space Operations Division. It does satellite tracking, and satellite tracking for many, many countries, United States, France, others. So we are supporting the satellite industry in that way. Another one is to support government policy and needs. So one example of that would be the Earth Observing Division. They get all the images that are required for government planning, settlements, water, agriculture, disaster management, fires, floods, that type of thing. But our main activity here is research. So our main goal is human capital development, which is a central goal of the government. And we do that through training, interns, master students, PhD students, and also postdocs. So we are training people in space science, but mainly it's through the techniques and methodologies. So people have a way of thinking that is about innovation and problem solving, whether it's space science or not. Those are the transferable skills. The sort of thing we do, for example, is in the Space Weather Center. In the Space Weather Center, we do space weather impact forecasting. That information then goes to the aviation sector for flight planning, or, for example, to shipping for communications planning when they're at sea and so on. And I can also give you one other example. Research that we have done, blue skies research in the Aurora, that had no apparent application, but for which we developed specialized image processing techniques, is now used by a company here in South Africa to do wildfire detection, mainly in forests, commercial forests. And we have demonstrated that the value that has brought in terms of preventing fires is worth billions of rands every year. Now that has nothing to do with space or space science, but the methods and the technologies and the way of image processing that has been done, now used in automatic camera systems, has found application in this area.
So the Boyden Observatory is about 27 kilometers northeast of Bloemfontein. The nice thing about Bloemfontein is that the galactic center moves right overhead in the winter. So in the galactic center, in terms of its coordinates in the sky, is also at -29. And obviously we know that is where the densest star fields can be found for astronomical studies. And that is why they decided to move the Boyden Observatory from Arequipa in Peru to Bloemfontein in 1927. In terms of understanding the world around us, if you study the universe, and in other words also the processes that is responsible for the generation of enormous amounts of energies, you can harness that knowledge and apply it here on Earth to solve our own energy crises. For example, we know, the problems that we have with Eskom, that can be solved if we understand the universe and how the universe basically creates energy in the most effective way.
In the words of Neil Armstrong, research is creating new knowledge. The critical and innovative thinking that comes with scientific research helps us to make sustainable choices and influence society in ways we could never have imagined 100 years ago. The SAIP's ongoing project, 100 Years of Physics in Africa, Past, Present and Future, prompts us to look back at the many inspiring stories of how physics is impacting our continent and producing world-class research. but we are also looking forward, stretching our minds and resources towards the goal of solving sustainable development challenges facing Africa and the world at large.
The last 100 years is being celebrated because in 1922-23, the International Union of Pure and Applied Physics was formed. The word physicist was coming into use, and those people felt it was necessary to unite. Einstein and Planck and Madame Sklodowska-Curie had turned the world upside down in physics, and this wave was propagating across the continents. So that's why 100 years, but what it means is not just 100 years backwards, but 100 years forwards. What will we look like 100 years from now? I'm involved with a number of people all over the continent, and I see a generation coming through who are absolutely fantastic. They are building labs, they're doing theory, they're collaborating, looking beyond the climate crisis. Could it be that it was African scientists who really got science diplomacy to work? Could it be that it was South African or African physicists who figured out how to build the cities of the future? I look into that kind of future and I look at the young people on the continent and I'm truly amazed. The potential of the sons and daughters of the continent is enormous.